Because of all the A's and B's and C's and D's. This is 8-27, letter C. Alright, so letter C says, oh, there's another, okay, for this sequence, 10.3, 11.5, 12.7, blah, blah, blah. Okay, so I think we're going to do the same thing again. We're going to have Wade and Dwayne. And we're going to have both their sequences. So this is super interesting to me. 9.1 plus 1.2n. I think that's arithmetic or something. T of n, 10.3 plus 1.2. Make a table of the first four terms. Are both forms of the equation correct? So we're going to do the whole thing, what we just did a second ago, again. Again, this one starts with the starting number, and then it kind of makes up for it with the n minus 1. This one, not sure. Well, at this point, they're only just asking us to make a table. So this would be n and t of n, and then just start plugging the numbers in. We have the first four. That's what they've asked us to do. So if I plug a 1 in, now notice this doesn't even look to be exponential. I can't help myself. I have this great curiosity. I just want to see what's going on here. Is it just adding, is it adding 1.2 each time? Is that what's happening? Okay. You guys promise? Yeah. Okay. So we know that this is not geometric, it's arithmetic, and we know it's adding. So now we're just going to go put a 1 in here. 1.2 times 1 is 1.2 plus 9.1. And that gives me 10.3, which I thought it did. Pretty sure this is just going to go like this. Just for time's sake, right? We don't have the next term. So let's see. 1.2 times 4 is equal to that, plus 9.1. Is anyone checking me? I got 13.9 for this one. Okay, this one should work the same. N minus 1, well 1 minus 1 is 0, and 0 times that number just makes 0, so now I got 10.3. This is n and t of n. Okay, so I'm going to kind of quicken this up here. We got 11.5, 12.7, 13.9. Should I check that last one? Because I kind of cheated a little bit. 4 minus 1 is 3, 1.2 times 3. I'm just checking it. Is that plus 10.3? 13.9. Okay, so that's the answer to letter C. Are they both correct? I'm going to say yes, both are correct. And then if you're ready for letter D, then we'll just go letter D. Read the math notes box about standard form of a sequence in this lesson. Dwayne's equations are based on the first term of each sequence, not on the 0th term. Why does Dwayne subtract 1 in both situations? Let's find the math notes box. So this is funny because Mr. Hendricks was talking about a textbook that he had used that always started with the 0th term, and I think ours said we're always going to start with the first term. I think it said that in the book somewhere. So I actually already wrote in my book the way that it appears in my Algebra 2 book that I teach out of, and in the pre-calc book that I teach out of. They just write it a little bit different. on here they're writing M, because I think that they're thinking of slope, because you guys know y equals mx plus b. So they're trying to make it easy for you, I think, by calling that M. But in most books that you see, they'll call that D for the common difference. I'm just pointing some stuff out that might be interesting to you. And on the geometric sequences, the other books that I teach out of, they don't call it B, even though it's B, just like an exponential equation, but they actually call it R for the common ratio in the other higher math books that I teach out of. But you can see that they're the same. That's the starting point, and that's the multiplier, and that's n minus 1. So using the standard form, okay, so we want to use, I think it's saying we want to use the standard form, or maybe it'll let us know when it's time. So those are standard form when it has the n minus 1 on it. Okay, so that's what I got out of reading that. So why does Dwayne subtract 1 in both situations? Does anyone have a nice answer for that? Yes. The starting number. That sounds funny, but that's why. Your book says because he's using the first term, which we're calling the starting number, of the sequence instead of the zeroth terms. That's why. So that's the end of this problem. Yay!